specialist. I made this in 2000. It's kind of sad that it wasn't more popular. So what do we have here? We can play with, let's make an anti-aircraft gun just for fun. So yay. So you can make it different explosiveness and stuff. Anyway, so let's make a gun, and this is how you make little rockets. And you can make little happy rockets. And so this is a program I wrote 2000. Okay, there we got a happy little rocket. You wonder how you aim the rocket? You come over here and you move it like that. That's how you aim the rocket. Okay, we need a little more thrust on the rocket. We're gonna make an anti-aircraft gun. Okay, so we kick this puppy up to 20,000 newtons, and we got a happy little. Let's make dots. Now let's do this up a little bit, and let's make a happy little. Okay, that puppy is. Let's zoom out. Okay. Okay, that is not how you aim a rocket. We're gonna make a V2. What am I have something in mind. I can't remember what I had in mind. These are too much thrust. Okay, let's just do. That's not what I had in mind. Okay, so we're gonna make a Patriot missile, or no, what do they call it? Pegasus. I'll tell you something. My dad worked on the B-1, and he worked on the Titan missile. And I'm a rocket scientist. This is what I do. And we are gonna make that gun shoot down the missile. So we come into here, and this is where we control the gun. And let's just do a little bit of simple addition here. We have, so this is what kids should play with. Okay, P4. So I'll come into here, and that is, there's this crazy, I forget, the help system got messed up because of crap. Okay. So, little kitties, there's an angle. What the hell is it? I think I have arg and angle. Oh, we want to take the angle. You do a 3-particle angle, and when it's 180, we want to shoot. Well, it's a little too late, but anyway. So let's just say at. Okay, if you become a master of SimStructure like me, you can have fun like this all day long, doing your control systems and gaining intuition on physics, because real intuition is hard to come by. Okay, so what are we doing here? Text. So I have done, look, it does water. Let's go ahead and put some water on here. And we got water. Let's make a, oh hey, why don't we do, if we have all day, we can do a simulation of Elon Musk and his little water. So this is the ultimate enrichment toy for kids. Way better than Minecraft. I am the enrichment god. And what are we doing here? I forget how this works. I think the fucking help is messed up. They changed it. Let's see what we got here. And so this is an interpreter that I wrote. I want to print the angle between a 3 particle, called particles, they're masses and springs. I started out doing, anyways, what are we doing here? DA? No, I think it's just A. What are we, what angle do we want here? We want 4, 4, 1, 3. So I think we say P4, P1, P3. Let's see what this does. Okay, good. I'm glad I was sensible. Okay. So I guess this is what we do all day, because we're measuring dick size and something like that. So that's the angle in radians. So we take 180 divided by pi, and when it hits 180, shoot, no. Okay, something's terribly wrong. Okay, we want to make these bigger so it floats because we stuck it on the water. So we go 5. That's a little extreme. So we go, this is my fun enrichment. I am the master clown king. Okay. So we got a floating gun. Oh, it's a I am Iron Man. Okay, so we got, what the fuck? Oh crap, did we crash it? Oh, I hate when that happens. We did crash it. Fuck. Oh, we didn't crash it. Oh, fuck. We didn't crash it. Fuck you. The CIA crashed it. Because they don't want the little sand niggers doing rocket science. That's what that is. Can you hear me? Okay. Fuck. Oh, it won't take too long. I'll save often. My computer crashes too. Oh shit, do we still got the, oh, we still got, yeah, I think we still got it. Okay, we used to have joysticks. Okay, so we got a gun. Okay, we didn't lose much work. Okay, what do we got? We got particle 2, 1. So we want 2, 3, and then the missile. We want 2, 3 missile. So we're going to go ahead and save often in case that happens again. This, I haven't used it in wine. I don't know what the fuck is the malfunction. It didn't do that in my memory, but I could be wrong. Okay, so I think we want a slow missile because that's better. Let's get rid of the light. 214. We want 214 to be 180. Do we not? That's a little too late, but anyway, so we go to command window, and this is how you play physics. Okay, number. Everybody becomes a fucking rocket scientist because it's fun. Angle 2. Oh, let's see. 1, 3. And we want to say 180 divided by pi because everybody knows. Everybody needs to know C. Okay, we have a, oh Oh, you're not thrusting. Okay. You need some thrust. So this is a little drone. Let's make it explosive too. What do you say? So we go, how much explosiveness do we want? How many tons of TNT? Where did it go? Particle. Explosiveness. This is one, it weighs 500 kilograms, so we will make it 0.5 tons. Okay, we got a rocket getting some acceleration, and when it hits 180 is when it is lined up. I don't think that's looking correct, George. Something's terribly wrong with our angle. Oh, that's 1, 2, 3. Of course that's wrong. That's our 4. Okay. 2, 3, 4. How about that? 2, 3, 4. Okay, this is looking better. So when that gets to 180 is when, okay, so there, 180. Okay, well, let's just shoot. Let's go crazy shooting when it hits 180. So we say G1 dot fire. I think we say fire count equals A P2 P3 P4, and we probably want this is a Boolean, so when it's greater than 1, I think you can, well anyway, I think it's just a Boolean. It has a reload rate, so we want to say oh, why don't we just say that max min min, we want 1. Oh, it doesn't matter. Yeah, it does. No, it doesn't. Let's take absolute value. Absolute value 180 minus angle. Oh, we can do a Boolean expression. Less than 5 degrees. Okay, that fire if it's less than 5 degrees. Okay, fuck. 1, 2, 1, 2. Fire if it's less than 5 degrees. Oh no. Okay, that did not work. I could. Is this correct? I think so. Let's see what happens if we say 1 million plus that. Let's see what that is. No, that did not work. I could swear that's how you make it fire. G1 fire count. Fire? Gunfire? What is it? Okay, so, oh, save. Save as. I don't know. Patriot. No, not Patriot. What do they call these? Pegasus or something? Pegasus. Okay, now we want to go explore the terminal window, and we want to say help. Okay, help who part? What do we got here? Help G1. How about that? Help who? What? Help on. I want to list the attributes of the gun. Help gun. That's not going to work. Fuck. Okay, I have the source code. Let's just. So the help compiler got out of date when Windows changed, and I fucking gave up on Windows. And so maybe let's see if the help. I think I have a help file, but it won't work. Maybe it will. It might work in wine, since wine is kind of out of date. So if we go to, where is, what am I looking for? I am looking for the installed, where is one? I think we want view, show hidden files. Then we go into here and we look for wine. Then we look for DOS drive, see? Program, x86, trivial solutions, SimStructure. Where's the help? I just want to see if the help file opens. Where the fuck? SimStructure.exe. I don't see the help. Maybe that's why it doesn't work. Okay, the help no longer compiled. I had to use the old help compiler. Okay, I'm kind of ruining my show. Okay, let's go ahead. Okay, so let's go to the raw help file. Resource help. Okay, this fucker. Oh no. I hate when that happens. Okay, open it as text, please. Fuck you. Okay. How are we going to do this? Open with gedit. Okay, Control F. I think we want gun attribute. How about that? Gun attributes. Control G. Gun attributes. Okay, I just have fire count, bullet fire, next opportunity. I was correct. You can abbreviate these, and for some reason it was not shooting. Why was the motherfucker not shooting? Okay, I was correct. I could make, did you know Ticketmaster had all kinds of enrichment mainframe type features. One of the things was abbreviations. You could enter commands as long as they were distinct. If you could enter abbreviated commands. And I almost made my C compiler handle abbreviated member variables, but that would be bad. So like you could make a structure with well, anyway, so in SimStructure you can abbreviate the member variables, and as long as they're not ambiguous, it's fine. It's fine with that. So why is this motherfucker? What is your malfunction? 1. Okay, that's better. Why didn't it like 10,000? Okay, so I like the look of this. Let's go ahead and put absolute value. Oh, I didn't do 1. Oh, that'll do it every time. Okay, 180. I don't know why I'm being a pussy and using degrees. I just happen. Okay, this takes a little bit of a while. Okay. Okay, so now we are making a turret. Let's go ahead and make this muzzle velocity. Now you can make big fat. So I have viscosity of air and all that stuff in here. I tried to make it accurate, but anyway, so this takes a while. Let's go ahead and crank this puppy up. We're gonna make this 20,000 newtons, and fucking teach those cocky little physicists what rocket scientists can do. Okay. Oh, little cocky fucking theoretical physicists. Okay. So now we want to make the, well, reload time down to 0.05. Hey, okay, these fuckers, the Pegasus is pretty crazy. I can swear it's down to about 0.01. Burp. Okay, you know that speed's not going to cut it. This could get crazy. So I don't even know, these numbers don't mean anything to me. I don't know if this is crazy. Okay, so now we want to, let's make these a little bit smaller. Touch. Okay. Let's make these explosive. Of course we want those explosive. Okay, they are explosive. Okay, fine. Okay, so let's get a little bit more sophisticated. So we want to take the acceleration. Let's calculate the time that it crosses path. This just takes sweat. I don't know, fucking. It's just algebra and hard work, and oh boy, isn't that fun. Okay. Are we having fun yet? Okay, class, let's talk about let's say double mass of the mass of the rocket is equal to P, is it 4, 5, 1, 2, 3, 4 and 5. I think it's 4 and 5. 5 and 4. So P5 mass plus P4 mass. Okay, and now let's print out the mass, or M, let's call it M, and let's go ahead and call that M. So these are 500 kilograms each. So the mass of the rocket is 500 kilograms. Okay, so the thrust of the rocket, let's say A is equal to mass, or acceleration, or force. So we want the thrust. So we say T1 saturation thrust, or thrust. We can make it, let's do that. We'll make it a variable. A is equal to T1 thrust in newtons divided by M, and let's print A. Okay, let's print A, and now we have, so we have 20 meters per second. Let's go ahead and change that, see if it changes. So this should be just barely greater than 9.8. When we were at 10, this is barely greater than 9.8. You can tell we got 10. Yeah, it's barely greater than 9.8. That's barely greater than 9.8. So that looks about right. Everything is pretty realistic. So now we are coming in here, and we are going down here, and let's save often. File, oh fuck. File, save. You know what? I think I had an autosave. Anyway, so let's go ahead and work this problem. Oh boy. Okay, so thrust, angle, or accelerate. Okay, now we want, as everybody knows, distance is equal to 1/2 a plus vt plus d naught. Okay, the other answer, please. At squared plus vt d of t is equal to that. Okay, so we have to solve the quadratic formula. Oh. Okay, so we need to know the distance to the bullet will travel. And are we having fun? This you get great satisfaction when you knock the fucker out of the air. I guess that's fun. Okay, so we have acceleration. Now we want to let's print. What if we take the angular change of the gun? So we have this angle, don't we? How does that change as it accelerates? Can we just work with the angle? I think the angle and the distance are pretty much identical. So let's figure out the angular rate of change. So we want to multiply by, we want to divide by the what is the, okay, we're going to work with radians instead of meters, and we are going to, we want to find out the thrust, we want to find out the acceleration in radians. We want to find the acceleration in radians, AR. And that shouldn't be too hard. That's going to be AR is equal to A divided by the distance from point, the muzzle, which is number 3 to number 4. Okay, so we take the distance P3, P4. Okay. Now this should be the this is the radians. I don't know if I can. What am I? High on drugs? No, I'm not high on drugs. What the fuck am I doing? Okay. So, for small angles, I don't know. I like this number for some reason. So let's go. So what is the angle in radians, and how can we see if we got an accurate, okay, anyway, so A squared, A, how about, what is the distances? So what we want is, so let's go ahead and call it D. D is equal to, that is the distance in radians. Okay. And is the accelerator, is this going to work? What do you think, people? Okay. We need to wrap and unwrap this fucker. So we want to say, okay, we want 180, so we want to say, when I was stupid and I thought it should be unwrap, but wrap is what you want. It's kind of embarrassing. So I was stupid and arrogant, and I made a fool of myself. So pi minus that, we want to go from minus pi to pi. All we're doing is converting it. So is it reasonable to conclude that the acceleration is in fact, now let's print the time, comma, oh, we can't, we have to use something other, let's say t, what do you call it, t minus 10 and counting. Let's just call, I use TT. T is actually time since the simulation started. It's a built-in variable. So let's say TT is equal to, okay, what do we got here? TT is equal to D divided by A square root D. So we want square root is take the order of operations in order. So the last thing you want is square root. The next thing you want is times 2 divided by A sub r. Let's see if this is an accurate time TT. It doesn't even matter. No, that is very wrong. Okay, I guess we need the V naught. We got to solve the fucking quadratic. The velocity matters. What if the acceleration doesn't matter? Oh, they both matter. They're both significant, so we have to solve the fucking quadratic. What if the... Okay, don't be a pussy. We want negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so we can go ahead. Let's go ahead and make a, b, and c. A, b, c. We already have an a. AQ, BQ, quadratic, CQ. So we say A quadratic is equal to A sub r. B quadratic. Oh, we got to say divide by 2, don't we? Ho, ho, ho. Okay. A quadratic and B quadratic. You know, this is dynamic. We're going to go ahead and change this as it changes. So this is we're going to correct this estimate of the intercept point as we speak. So this is going to be P4 dot or let's say, yeah, we want to say the dy. We could say there's a speed of dx and this is the y velocity. We're going to correct it over time as we go, and c quadratic is equal to d. Let's go ahead and, so this is the distance in radians. We'll get rid of D. Okay. A quadratic AR over 2. Oh, but this needs to be in radians. Let's go ahead and save often. File, save. Okay. So how do we feel about this? What about the sign? Okay, the velocity. Let's make the sign correct. So these are all increasing upward. So is that's technically that's a negative radian. Well, anyway, positive radian. Okay, so AR divided by 2. dy is positive, yeah, and C. So this is the wrong answer. This needs to be, those are increasing up. I don't even know about this. I'm confused. I think we want this, seems to me this is the other direction. But we didn't even check, see what we have. So let's go ahead and print CQ, see what we got. I don't even know what I'm doing here. Let's see. Error. Okay, we have a distance. Let's go ahead and get rid of the T. Okay, that is getting smaller. That's good. I think that's good. So now we want to say TT is equal to, and we want one or the other. Let's go ahead and say B negative BQ. Anybody want to guess? Minus square root BQ squared. I think we have minus 4 times AC AQ times CQ. We might have a, I don't know what we, okay, let's go ahead and we want to start printing. This is our estimate of the time to, let's save this. The other answer, as they say, I don't think it's going to help. Okay, we have to, we're not even close to done. So we want to, let's get this fucker positive. Okay, 1/2 AT squared. So we have a positive value for this, a positive value for that, and we are looking for the, we want this to be zero, obviously. Okay. So we want D to be, that is the distance we're closing in. So this needs to be like a big value. What do we got for CQ here? This needs to, we need to fix this puppy here. What do we got here? Okay, it looks pretty good actually. So it's a positive value. I think we want to, we want a negative value. Yes, we want a negative value. Okay. Okay, that looks good. Now, let's look at TT again and see what we got. I think we tried this. Okay, we have a negative b plus or minus the square root b squared. Oh, what do I got? Plus 4ac, minus 4ac. Let's try plus 4ac. Okay, let's do that. Negative b plus or minus square root b squared minus 4ac all over 2 times a. Okay. So we had a negative value. Now was I... What... a... A is the thrust divided by the mass. AR divided by the distance. AR divided by 1/2. Okay, we have that. We had a negative. Let's make sure CQ is correct. So it should be. Okay. Now maybe. Okay, so C is in radians. This is AR. dy. Okay, now that's in radians. Is it accurate to assume that we can use radians? I think so. I don't really know. I don't know what gave me that idea. Okay, what is the malfunction here? It is getting more negative. How did we get... Oh, wait a minute. Let's see. Okay, now I'm going to... Okay, the acceleration is 0.08, the velocity is 0.16, in order to go, let's make the velocity constant and not accelerate and solve it, and then do the acceleration. So let's say file. How can we do that? If the velocity was, if the acceleration was 0, let's back off on the acceleration and let's put it back. Let's just watch. So this should make it come down to the velocity. So when the velocity is 0.01 and the distance is 0.35 radians, we're showing a time of 0.13 seconds. That's way off. Okay, what it should be is 35 seconds. So, so we got to fix our formula. Where did we? I don't think we're accelerating 0.04 because in 1 second it certainly, the velocity does not increase by 0.04. So we got a problem. The A is, we got a major problem here. Okay, so the acceleration, meters per second squared, P. Anybody good with radians? Let's try this in degrees. Just let's see. I just want to see if this makes sense. We could work the problem in degrees. We don't have to use radians. Let's work the problem in degrees. Kind of retarded. Well, anyway, or let's just print these in degrees. I don't know. I got a bad idea about working the problem in degrees. Okay. So, the velocity, the acceleration does not change by that amount. It's not correct. So, the thrust divided by the mass it's not a big enough distance. It's not a big. Do we need to take the? We do have a. We do have an arg function. Why don't we just use the arg function? The angle is the angle too big for the sine for the radian approximation? Maybe. Am I high on drugs? Okay, let's see. Between 3 and 4. Let's look at the thrust in. No, it's not. Okay, let's see if the velocity we are showing is correct. So about 4. So it should change by 0.06 per second. I think it. Okay, the velocity doesn't bother me. The acceleration is not correct. The acceleration is way fucking off. Okay, let's work the problem in okay, let's see. Humility before honor. You always get humiliation before glory. Always humiliation before glory. So we take A. Okay, our acceleration is 10 meters. Oh, we didn't take out gravity. No wonder. Okay. Thank God we figured that out. Let's save this. Okay. What an idiot. Okay, so I think we have G as a defined variable. Where's G? Okay, let's see if the acceleration is about point. God, please help us. Let's see. Okay, let's take this step by step. So it should be about 35. Why are you not showing 35? What are... Okay, so negative b plus or minus square root b squared minus 4ac just to be interesting. There are two solutions, and T1, T2. Oh, we got T's. Okay. Thrusters. T is thruster. Okay. Oh, you're high on drugs, Terry. What are you doing? You're high on drugs. Okay. 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 Reset. One that needs to be negative. The C needs to be negative. Why is the C not the other? How did that happen? I could swear I had it correct. Okay, so we are saying T1 and T2 are identical. What the fuck? TT. The acceleration is very small. It should just be C divided by B is the approximation, which should be about 400 divided by 8. It's about like 40. And we are showing 5.2. Negative B plus or minus the square root B squared, what is 4AC, all over 2. Is it 2AC? I can't remember. It's just 2A, isn't it? Why am I? Why are we showing the same value for T1 and T2? Let's print discriminant. The discriminant is equal to discriminant okay, that crash was not my fault, honestly. So now, are we having fun? Just remember, humility before honor. You get humiliated. Well, that's not how you spell Pegasus. Humility before honor. Pride. You get humiliated. Okay, so what is... It is my fault. What the fuck is going on? Shut down. Why the fuck you fucking... So it is my fault. I think we have a... Oh, we have a square root of an... Oh, of course, being an idiot. We have a square root of a -1. Okay. So... let's print... Let's not take... Okay. Oh crap, what the fuck happened? Print the discriminant and why is the discriminant 0? Motherfucker. What is BQ? BQ is 0. Why is BQ 0? BQ is 0.0081. The fuck is your problem? The fuck? That's better. Okay. BQ is 0.005. That's better. Okay. Now let's look at BQ squared. This should be very tiny. BQ. Okay. Now let's look at AQ times CQ. That is a pretty hefty negative. negative b plus or minus square root b squared minus 4ac. B squared minus 4ac. All over 2a. Negative b plus or minus b squared. B squared minus 4ac. Let's go ahead and squared. What should this be? This should be with about 3 zeros. Maybe the square is not the correct operator. Fuck. Okay, that will cause problems. Okay, so that's an XOR, you idiot. But anyway, I wrote this C compiler. It does have a square operator, but I think it's the okay, I think it's this. What did I use for the square? What did I use for the I used the do I have to do power? No, I have a let's just I can swear I made an operator. Nope, I didn't. It's power. Okay, fuck. Okay, well, I hate when that happens. Okay, 26 and negative 26. So we want the T2. So it will intercept in 9, 8, 7, 5, 4, 3, 2, 1. Okay.